Hey everybody, and welcome back to another video. Now I know most of you are probably not going to watch this, but I really recommend that you do because this really does explain a lot the mechanisms of tinnitus, noise-induced tinnitus, mechanical factors in tinnitus induction, and also how hearing loss or hair cell death does not directly cause tinnitus. Ergo, the brain does not quote unquote try to fill in the gaps of the lost hearing. And this is exactly why people with hearing loss sometimes do not get tinnitus and vice versa. Now, first of all, we're going to talk about inflammation and excitotoxicity. Now, what is excitotoxicity? Excitotoxicity is a very harmful process when neurons or nerve cells are overstimulated by excessive glutamate activity. Now, as we all know, glutamate is the dominant, I guess you could say, excitatory neurotransmitter when it comes to initiating action potentials. And as we know from the previous videos, action potentials are the main communication mechanism which can be compared to electricity between nerve cells. And due to principles of spike timing dependent plasticity, we all know that rapid firing rates of action potentials eventually leads to the synaptic connections being strengthened even further by the addition of new AMPA receptors to the cell membrane due to calcium signaling. So when the body feels that there is a lot of action potentials being fired due to a lot of noise or just a lot of stimulation, then it will see that these connections between the neurons are important, and it's going to increase the amount of receptors on the cell membrane, the nerve cell membrane. And these AMPA receptors are actually what the glutamate binds to. Now, what does excitotoxicity actually lead to? As I've mentioned before, it leads to calcium overload in the cells, which means that the overstimulation actually leads to more calcium influx, a huge cascade of calcium influx actually into the nerve cells. And again, long-term potentiation of the synaptic connections between the nerve cells is actually signaled by calcium signaling. So when there is a calcium overload in the nerve cell, that actually means that long-term potentiation is initiated much, much easier. Now, another thing caused by excitotoxicity is something called mitochondrial dysfunction. Now, I mentioned this in my previous video, and this is actually something that Liam Stops Tinnitus always talks about. It's not actually a root cause, but it is actually something that can lead to cell death. So the mitochondria is the powerhouse of the cell, meaning that absolutely all processes within the nerve cell are given energy by ATP that is coming from the mitochondria. Now, if the mitochondria stops working due to stress or overwork from the excitotoxicity or the calcium overload, I guess you could also say, then it is unable to provide sufficient energy, leading to a failure of many intracellular mechanisms, which actually does include the sodium-potassium pump, as well as numerous other things which are meant in the nerve cell specifically to regulate the ion balance inside the nerve cell, basically making the nerve cell either just maybe more biased towards a positive charge, which will eventually lead to more chances of an action potential being fired, which will then of course lead to more cascades of excitotoxicity down the neural pathway. Another thing that can occur due to excitotoxicity is oxidative stress, which is just basically damage from harmful chemical reactions. And all of this together can lead, and it does lead, to cell death. Now, what is inflammation? I'm sure many of you people actually know what this is, like when you get a cut on your body. It gets inflamed. for example. Now, inflammation is basically the body's immune response to injury, and it can actually amplify excitotoxicity in several ways. One of them is called microglial activation, and this is when the brain immune cells, which are called microglia, release inflammatory molecules like TNF-alpha. And this actually increases the sensitivity of glutamate receptors and worsens the excitotoxic stress even further. And inflammation also reduces the ability of the cell, specifically the nerve cell in this case, to clear excess glutamate, which actually prolongs excitotoxicity. And both processes generate reactive oxygen species, or ROS, which actually damages the cell even further. So inflammation and excitotoxicity form a destructive feedback loop. Inflammation worsens excitotoxicity, and the cytokines released during inflammation sensitize the neurons, increasing their vulnerability to excitotoxic damage even further. And excitotoxicity can fuel inflammation. So damaged neurons, they release danger signals that activate microglia, which perpetuates the inflammation. So basically, this vicious cycle compromises the blood labyrinth barrier, and this allows inflammatory molecules and immune cells to infiltrate not only the inner ear, but in some cases, like mechanical damage, like whiplash, for example, these things can actually infiltrate the dorsal cochlear nucleus as well, and that's absolutely insane. So when inflammatory molecules enter the dorsal cochlear nucleus due to the degradation of the blood labyrinth mirror, it sensitizes the neurons and the DCN even further, which means that they become even more hyperactive to stimuli. So basically, what do we have? Excitotoxicity, which is the overload of the nerve cells with too much excitatory neurotransmitters like glutamate, can potentially lead to inflammation, which then actually in turn leads to more excitotoxicity, which then can potentially just lead to even more inflammation. Now, inflammation can actually come from many parts of the body. Now, I mentioned that in my previous videos that the dorsal cochlear nucleus is very closely connected to the somatosensory pathways. So that means the trigeminal cervical nucleus, for example. And if a person damages his trigeminal cervical complex, for example, with whiplash or just a neck injury or anything like that, or somehow damages his cranial nerves, this inflammation can actually sensitize not only the neurons in the trigeminal cervical complex, but because of their connection to the dorsal cochlear nucleus, it can actually sensitize the fusiform cells as well. And that's why you see a lot of people get tinnitus, for example, after some traumatic mechanical injury like whiplash. Now, for the part that you are all waiting for, which is the separation of hearing loss and tinnitus. Now, hearing loss, as we know, can be and predominantly is the death of hair cells in the cochlea from, you guessed it, excitotoxicity and inflammation. And we all know that hair cells do not regenerate. They lack the capacity for plasticity or reorganization or regeneration. And that's because they are terminally differentiated, and they also do not regenerate synaptic connections. Now, in the dorsal cochlear nucleus, when cell damage or cell death, fusiform cell death, for example, or cartwheel cell death, happens due to excitotoxicity or inflammation, this can actually induce homeostatic plasticity, which I mentioned in my previous videos, which is the ability of the nerve cells to reorganize their connections to try and recover this damage, I guess you could say. Now, this does not happen because of lack of input. This happens because of a cascade of excitotoxicity and potentially inflammation that gets passed down the auditory pathway from the hair cells, down to the dorsal cochlear nucleus. But this is just I guess you could imagine it as a cascade of way too much glutamate, for example. It infects the rest of the auditory pathway, leading to excitotoxicity in other places further up the auditory pathway. So you can imagine it like an electrician or an engineer who is frantically restructuring the circuits of whatever device he is building, which you can imagine to be the dorsal cochlear nucleus, and the wires being the fusiform cells or cartwheel cells. And instead of actually replacing them or, putting in new lengths of wire, which is not really possible because nerve cells do not really regenerate, he just takes these connections and he takes these wires and he just kind of connects them to each other to make sure that the signal is still being passed through, even though some parts of these wires degraded. Now, as I've mentioned in my previous videos, homeostatic plasticity can sometimes fail. And this happens when the brain tries to reorganize these connections and it actually engages neurons or engages neural connections that are not supposed to be engaged, like, for example, between the fusiform cells and the somatosensory pathway. And what this actually does is it creates another vicious cycle of feedback loops, self-reinforcing hyperactivity that cannot go away on its own, ergo tinnitus. Well, it can go away on its own, but most of the time it does actually, but for some people it does not. And the more feedback loops that you have, ergo more somatosensory issues or just, other stuff like that, the less likely homeostatic plasticity is to kick in. Now, whether or not these neurons die depends on the person's personal or unique factors. So, for example, some people have more potassium channel resurgence, which means that the ability of their neurons to regulate the excitatory signal as it passes down the axon is recovered, and that means that these feedback loops or this hypersynchronization is not actually happening after a certain period of time due to the regulatory systems or the regulation in the body or the nerve cells actually activating correctly, ergo the homeostatic plasticity working as it's supposed to. Now, hair cells can also actually die from excitotoxicity, or they might not die from excitotoxicity. That really depends. Whether or not the hair cells die, again, depends on genetic factors. So, for example, the cochlea gets a very, very strong signal or a large amount of sound energy, and this causes the cascade of excitotoxicity to occur. And this excitotoxicity, ergo the excess glutamate release, happens and it is passed down the auditory pathway to the dorsal cochlear nucleus. Now, whether or not this excitotoxicity actually damages the fusiform cells or the cartwheel cells depends again on genetic factors, and resilience as well. So, for example, a person's hair cells can die, and then, of course, he will get hearing loss, objective hearing loss. But his homeostatic plasticity can be successful in the dorsal cochlear nucleus, which means the person's hair cells die, but because his fusiform cells or cartwheel cells restructure their connections without engaging the somatosensory pathway or without engaging the synaptic connections to the somatosensory pathway, ergo the parallel fibers of the granule cells, if they are not engaged in this homeostatic plasticity, then maladaptive plasticity will most likely not occur, and the fusiform cells will successfully restructure or reorganize their synaptic connections. So when a connection is disrupted due to nerve cell death or due to synaptic degradation from excitotoxicity, these connections actually latch on to any fusiform cells that are nearby just to make sure that the connection is not disrupted, because we need to process these signals to actually live and to be able to hear and be able to move move and to do everything. So this actually, homeostatic plasticity, is very useful when damage does occur to save the person from literally losing his hearing for a certain period of time. And it happens really fast. But unfortunately, if a person, for example, has some mechanical issues like cervical tension or just anything like that that can actually cause aberrant activity or synchronization, or just, too much activation of the somatosensory pathways, this can actually lead, as I've mentioned before in this video, the homeostatic plasticity to engage or start latching on to the synaptic connections to the somatosensory pathway, which then introduces these feedback loops of neuronal excitability, ergo tinnitus. Now, again, overall, let's go through it again. Hair cell death, which can occur due to excitotoxicity and inflammation, does occur, and it can occur. And this excitotoxicity, or this glutamate release, excessive glutamate release, can be passed down the auditory pathway to the ventral cochlear nucleus, dorsal cochlear nucleus, and subsequently further up the auditory pathway. Sometimes these hair cells can die from the excitotoxicity, and sometimes they don't die from this excitotoxicity. And again, sometimes the dorsal cochlear nucleus does have failed homeostatic plasticity or maladaptive plasticity, which then can lead to synchronization, feedback loops, and tinnitus, and sometimes it doesn't. So what can we get from this video? Tinnitus is not caused by the brain filling in the gaps from hearing loss. It is a combination of distinct interlinked mechanisms. And while hearing loss does stem from hair cell damage, tinnitus results from the maladaptive neural responses in the auditory pathway, like the DCN. Inflammation, excitotoxicity, and physical trauma, they all form a vicious cycle that perpetuates this damage and feedback loops. And yes, hair cell death that occurs from excitotoxicity and fusiform cell death or damage that occur also due to this excitotoxicity, they are related to each other because this cascade of over-release of glutamate would not technically happen, it can actually happen from the somatosensory pathways, or further up in the higher regions of the brain, it actually can happen. But if we're talking specifically about noise-induced tinnitus, of course, this excessive glutamate release does not occur without the excitotoxicity or excessive glutamate release from the hair cells, of course. But whether or not the person loses hearing or gets tinnitus depends on separate factors. If the person has somatosensory engagement, then there's a higher chance that the homeostatic plasticity in the dorsal cochlear nucleus will fail, leading to maladaptive plasticity or tinnitus. And the person who loses his hearing has his hair cells die from this excitotoxicity. But the excitotoxicity that causes the hair cells to die does not absolutely guarantee that the person's dorsal cochlear nucleus will become hypersynchronized. So yeah, every ENT or audiologist who tells you that the brain is filling in the gaps of the lost hearing is a liar and should read more. Now you're probably wondering, oh, but why does hearing loss sometimes correlate with the frequency of your tinnitus? Well, that's because the glutamate release, or the excessive glutamate release that happens from the hair cells of specific frequencies get passed down the auditory pathway to the fusiform cells that are also actually grouped together in specific pathways for specific frequencies, causing the fusiform cells of these specific frequencies that just happen to line up with the frequencies of the hair cells, I guess you could say, are the fusiform cells that become most often hypersynchronized, just because the excitotoxicity is happening in the pathway that is connected to the hair cells responsible for reacting to these vibrations, ergo sound, of certain frequencies, and sending it further down the auditory pathway to be processed by the groups of fusiform cells in the dorsal cochlear nucleus, or these pathways that are responsible for these specific frequencies. Now, what can be done to address this? Well, obviously, a person should always make sure that their mechanical cofactors that I've mentioned in my previous videos, like cervical tension, TMJ tension, all that, is treated. The person can also follow a low histamine diet, which decreases inflammation in the body overall, and it's shown to help some people with their noxicusis as well. Also, NMDA receptor blockers, they do prevent excitotoxic damage due to preventing the massive calcium influx. And also some anti-inflammatory drugs can also be used. But the biggest and most coolest thing that we have right now is NHPN 1010. And it actually, what this does is that it shields the auditory structures by mitigating inflammation and excitotoxicity. So, for example, if a person is taking NHPN, which is a combination of NAC, by the way, and HPN07, they can actually prevent hearing loss due to preventing excitotoxicity and inflammation. The problem is that NHPN 1010 is not being released to market anytime soon for some unbeknownst reason. It's being withheld by the company that is currently, that has developed it. So we don't know. If NHPN 1010 was on the market, people would literally not get hearing loss ever, and also never get tinnitus due to the prevention of excitotoxicity and inflammation. So why is it not on the market? Who knows? When it will be on the market? I don't know. Do I wish it was on the market? Yes, I do. But that's to be seen. So this is my scientific rant for today, and I'm going to link the full papers that I wrote on both of these topics in the description and in the comments section below. That's it for today. Peace.